What page? 10. All right. So vertical angles, when we think of vertical angles, we think of an X. You see on the page here? You see the X in front of us? Okay, vertical angles are on the opposite sides of the X. So our example here would be angles 1 and 2. These are what we call vertical angles. So first thing, we say they're not adjacent to each other. Do you see angle 1 is here and angle 2?
Oh, they're not like touching.
They only meet at the point, but they're not like next to each other. Right, they don't have connecting sides or rays. Okay? So whenever we have intersecting lines, we would have vertical angles. So I could also draw like, let's say here, I could put angles 3 and 4. These would also be vertical angles. So they can be on the top and the bottom. Okay, so adjacent would be if they are next to each other. Okay, so let's say I make intersecting lines. 10. You see 5 and 6?
Yeah.
Those are next to each other.
Oh, I see.
So 5 and 6 on the board are not vertical angles.
They're adjacent.
Yeah, these are not vertical. They are adjacent angles.
Ow, my back.
Okay. You see the difference between the two vertical? So vertical angles, adjacent angles. Good? These are just another example of vertical angles. So vertical.
I know, but technically, don't they share a line? Or?
No, they don't. So here, watch if I trace over. Here's angle 2. Here's angle 1. Do you see how the actual sides, like if I were to trace over angle 2, does that trace over any of the same sides of angle 1?
No, for some reason I thought it was like there, that line.
Oh yeah, no, just the angle parts. Okay. All right, now vertical angles, these are adjacent to each other. Okay, and look at the first part of linear pair. What do we notice about the first part of the word? What is it? Line. Okay. So anytime you have a line and then you have a side extending from one of those parts of the line, you have a linear pair. So actually it's interesting. I picked 5 and 6. I did that not on purpose. See how if I covered up this 5 and 6, they form a line? So this would also be an example of a linear pair. Okay, so linear pair versus vertical angles. Linear pair are next to each other. Vertical angles are not adjacent, not next to each other. Okay, so let's look at the examples of the numbered angles, and we just want to determine which ones are vertical, which ones are linear pair, and which ones are neither. Okay, 1 and 2, what do you think? They're adjacent, so therefore we're going to call this a linear pair. Okay, what about 3 and 4? Okay, let me ask you a question. Are the lines straight? If the lines are not straight, do you see how this one like bends downward? That's neither. Okay? Okay, versus, are the lines straight when in part C?
Yeah.
Okay, what kind of angles are 5 and 6?
Vertical.
Vertical. Those are verticals. Do you see the difference between the 3 sets? So these are vertical. Good? Good?
Do you think it's linear pair and vertical angle? Can you just say linear and vertical?
Say linear pair because we're talking, because I don't want you to just think, because linear can refer to an equation, linear can refer to, whereas vertical, it only refers to angles. Okay? All right, linear pair postulate. So this is a rule, and it has to do with how many degrees, or what does a linear pair add up to? Any ideas? What do you think? Look at angle 1 and 2. If you had to guess how many degrees those two angles would add up to, what do you think?
1 and 2?
180.
1 and 2.
I know.
What?
180.
Yeah, 1 and 2 would be 180.
It would be 180.
That's
Do you
flat.
remember what we call those angles when they add up to 180? Okay. Here we go. Linear pair are always supplementary. So that tells us that the measure of angle 1 plus measure of angle 2 is always 180 degrees.
For a second, they were asking what's like I think it's like one's like this one, right? I think like one's a little like middle like center one.
The middle and the
Whatever.
whatever.
You get
Does it make sense that these are supplementary?
Yeah, why? See a line, the arrow going up.
Okay, so it has to.
It's a bias.
Okay, think about if you had a like, let's say you had a coordinate plane, just right. So imagine like back in algebra or pre-algebra, right? You have it. We call this a coordinate plane with an x and a y axis. If you were to go all the way around a circle, how many degrees is all the way around the circle? 360 degrees. So think, what would be half of that would be 180. So if I look at angles 1 and 2 and I think, oh, this would be a half of a circle around, half of a circle is 180 degrees. Okay, so does that make sense when you think of it as half of the circle? Okay. Avery, you have a question?
So they always do 180.
Yes, always 180. Okay, so let's take a look at example 2. We want to find the measure of RSU, so we're looking for this angle measure. So how are we going to find the measure? Good, we're going to take 180 degrees. We're going to subtract 16. 118? We agree with Jonah? David?
Yeah.
180 minus 62, do you agree? Is 118?
I have a question.
Yeah.
Like, will there ever be situations where it's not 180 and it could be like 90 or something?
Not with a linear pair. Yes, there are situations where it could be 90. That's on the quiz that everyone took yesterday, except a couple of you. When it said what word stands for equal 90? Complementary. So if I said two angles were complementary, we would make them equal to 90. Okay? But supplementary or linear pair has to be equal to 180. Okay? So different situation. Okay, next we have vertical angles theorem. If we have vertical angles, then they are not complementary. They are congruent. What does congruent mean again? They're the same. Okay, so that says angle 1 has to be congruent to what other angle? 3. So I'm going to put an arc around 1 and 3. So if angle 1 was 50 degrees, angle 3 would be 50 degrees. And then what are the other two vertical angles?
Angle 2 is equal.
Good. So I'm going to put 2 arcs here. So angle 2 has to be congruent to angle 4. So here's the thing. If I give you one angle measure, can we find the other 3 angle measures? We can, yeah. Because what's 1 and 2? They form a line, so we call them a linear pair. So if I knew this one, I could find this one, I could find this one, I could find this
Is it
one.
because linear pairs are supplementary? So that's
Linear pairs are supplementary, vertical angles are congruent. Those are the 2 important things that we want to keep in mind today. Okay, good. All right, let's look at measure of angle CED. Where's CED? It's on the, so CED is over here. Yeah. What do we notice about these 2 angles? They are vertical angles, so they're congruent. Yeah, this has to be 50 degrees. So CED is 50 degrees. Okay, this is kind of like what I just had mentioned. if we have one angle measure, we should be able to find all the other angle measures. Well, if this is 35, what other angle is 35?
2.
So this is 35 degrees because these two are congruent. Okay, now we need to look at linear pairs. Angle 1 is a linear pair to 35, also 3. So how would we find, let's go with angle 1. Let's do this one.
That's the
Add
other
them
two.
and then you subtract
Yeah, what do these have to add up to?
180.
180. So if I know measure of angle 1 plus 35 equals 180. Good. So I get measure of angle 1. Oops, there's supposed to be a 1 in front. 145. Okay. So no work for the last one. If angle 1 is 145, what's angle 3? 145. So we always just want to remember that the vertical angles on the opposite sides, those are always going to be the same. Good. These two are the same. These two are the same. Also, if I wanted to check my work, what would all 4 of those angles have to add up to? All the way around this.
360.
If I check 2 of them, it's 180 and 180. But if I went all the way around, 360. Yes. Yeah, real quick. Okay. How about, all right, let's see if we could do, did anybody, I see some of you working ahead. Did we get B and C? Okay, I'll give you guys a minute and then I'll ask for. Ooh, let's see. Unfortunately, oh, I have like a little basic calculator. Oh yeah, sure. Just yeah, I just sorry, I left all the other. We're gonna have to take this out. Okay, did we? Joni, you said you had B, right? What'd you get for angles 1, 2, and 3?
For angle 2, I got 28.
28, good.
And angle 1, 3, I got 152.
152 for 1.
Because I did 28 minus.
Yeah. Do we agree with that? 152? Okay. Who wants to help me out with C, Avery? Good. So 67 for angle 2.
And then 180 minus 67 equals 113.
Good. 113. So 113 for angle 1 and 3. Excellent. Okay. Questions so far? I think the next page is the last thing, right? So the last page is... Last page. Okay, now we have to solve for some variables. Okay, so now we kind of incorporate our algebra knowledge. How are we going to solve for the variable in part A, Minnie?
Do you just do 2y equals 4y minus 42?
Yes. Why are we going to make 2y equal to 4y minus 42?
So, like, because the y's can't be on the same side.
Ah,
Could it also be 4y minus 42 equals 2y?
yes. We can switch those around. It doesn't matter which one we put. How do we know they're equal? What angles do we call these?
Concurrent.
They're congruent because they are a vertical pair. Okay. I'll just subtract 4y, but again, you can have it set up different. And what do we get when we divide both sides? What do we get for y? Negative 21 or positive?
Positive.
Positive.
Positive. Yeah. The way I did it a negative divided by negative.
It's negative 20.
It's going to be positive because I have a negative divided by negative.
It's 21.
It's 21.
And then we don't need to solve the
So I didn't ask for the angle measure. Now, what if I asked for one of the angle measures, just like on the quiz? We just plug it back in.
That would be 42.
42. Okay. All right, what do we do for B? So same thing, we're going to make these two. These are vertical angles. So I'm going to have 2r plus 3 equals 89. So subtract 3, we get 2r equals 86. We're going to divide both sides by 2. Who said that? Was that you, Minnie?
Yeah, it's
43, good.
This case,
Yeah.
for C, why does it say there's 2x and it's saying there's a y?
Oh, that's a mistake. Sorry. I was revising old notes, so yeah, in part C that should be an x equals.
Where?
And same thing for D, that should be a t.
Oh wait, you crossed out the Y, right? And you put
Yeah, it was just a
was
typo.
confused.
Sorry, I asked you to solve for the variable, but there's no y in this problem. Okay, same thing for this one. We're going to make them equal to each other. So I have 3x equals 2x plus 16. Yeah, I'm just subtracting 2x from both sides. X equals 16. Okay, now the next one we're solving for t. Are those two vertical angles? Mm-mm. We call this a linear pair. A linear pair. What do we remember about a linear pair? They're not equal, but they're equal to 180. So Fred.
20t plus 5 plus 15.
Okay, so 20t plus 5 plus 15t. Sorry about the t's. I know t's and plus signs don't mix well. I know, in math, when I make a t, I put like a little curly end to it just so I can see the difference. Okay, from here I have to find a combined like terms. So 20t and 15t is 35t. And we have to subtract 5 from both sides. So 35t equals 175. I see some calculators out. Great. Aiden, did you?
5.
T equals 5. Good.
What's 35 Oh, 30. Oh, so 175.
175 divided by 35 gives us 5. Okay, questions so far? So in this whole lesson, we only had 2 different ideas. You either make them equal to each other if they're vertical, or we make them equal to 180. Okay, last example. Okay, now we have 2 different variables. We want to solve for x and y. Can we solve for x first?
Yeah. No.
Do I have any idea what to do with x?
Maybe
Do I know what's
three-
across from here?
Maybe we just put another 3x there.
Yeah, but is that going to help? If I put 3,
Solve for what?
so we should solve for y first.
Then how would we find that?
Okay, we'll deal with x first. We're going to solve for y.
I get how to find x.
Okay, so I'm going to solve for y first. What am I going to do with those 2 expressions? 8y minus 102 and 2y plus 6. Are we going to make them equal to each other, or are we going to make them equal to 180? Equal to each other because they are vertical angles. Remember when they're on opposite sides. So I have 8y minus 102. I'll subtract 2y. I get 6y minus 102 equals 6. What next? I have to add 102 to both sides. Remember, whatever we do to one side. I noticed some of you yesterday, which was really good, on the quiz, you were getting some really weird numbers. You were like, how am I getting 83 divided by 5? I'm not going to give you some weird answers. So some of you had like a plus here and a minus here. So you always want to just double check your work. Here we get 108, right? Oh, you got it? What'd you get?
18.
18?
Yeah.
Excellent. Okay, so almost done. I need to now figure out what x is equal to. Idea is there. There's more than one way to solve it. Avery, what do you think?
Doing the 2 times 18 plus 6.
Okay, can I plug 18 in here to figure out this angle measure? Okay, let's do that. So 2 times 18 plus 6. Okay, on the calculator. So 2 times 18, 36. 36 plus 6 is 42. Okay, so this angle here is 42 degrees. Does that make this one over here also 42?
Yeah.
Yeah. So just so you know, these are both going to be 42 degrees. Now, can I set up an equation to solve for x?
Yeah. Well,
What would that be?
3x
Equals.
equals.
138, 180, 138.
Wait. Okay. 3x plus 42. What kind of angles when they're next to each other like this?
Oh, sorry, subtracted the.
Oh, that's okay. They have to add up
Why are
to.
you doing 3x plus 4?
Oh, because they make a linear pair. You see how they're next to each other? And what did we say a linear pair has to add up to? 180.
Wait, I have a quick question.
Sure.
Why did you sub in the y?
Because I didn't have enough information to figure out what x was until I figured out what the angle measure is here.
Okay.
Okay, so now I'm going to take 180 minus 42.
It's 47.
138, I think I heard.
138.
138.
And then divide by 3 to get 46.
And then we divide both sides by 3. And what did we say? 40.
6.
Agree? Do we agree? I see some of you with calculators. Excellent. Okay. Good.